Actually, in our previous class, I already discussed about the different types of NC, CNC, and BMC. And what are the components that are going to make this kind of CNC for reducing the human effort for making the manufacturing process. In this class, actually, we are discussing about the different types of control system. Basically, we are having the different types of control systems are used in our computer numerical control. So general types of control systems are like hydraulic control system, pneumatic control system, open loop control system, and closed loop control system. Based on their specification and the components requirement, it may be classified into different types. Okay. In our previous session, I already discussed about the what are the components that are required to make the hydraulic control system as well as the pneumatic control system, and what are the basic difference between the hydraulics and pneumatics are I already discussed. Today we are going to discuss about the closed loop system and open loop system. Okay. So mainly, but first of all, what is the basic difference between the closed loop and open loop system means in our open loop system there is no feedback device, which means we are giving the input and we are taking the output. There is no comparison between these inputs and output values. Okay, in our closed loop system we are using different types of feedback device, like either it may be sensors or encoders or different types of feedback devices are used in our closed loop system. Okay, so in our previous class we have discussed about the hydraulic system. It is the best example for closed loop system because the entire cycle will be a closed loop. We are starting the process between the tank, it will be ended by again the tank, and also we have to use the different types of sensor for avoiding the different leakages are provided in our hydraulic system because pressurized fluid used as a fluid medium, so some of the leakages may be occurred during the working of hydraulic system. So at that time, sensing of leakages and avoiding the leakage purpose, we can use the different types of sensor in our hydraulic system. So that is the best example for closed loop system. Okay, and the pneumatic system, which is the next example for an open loop system. There we are producing the compressed air, which is an fluid medium. It will be directly controlled by the regulator, FRL unit. So we can directly regulate the amount of pressure level by using the FRL unit, but we are not using the sensor because the after completing the operations, the operated compressed air will be directly sent into the atmospheric air, which will be with the help of either muffler or quick exhaust valve. So there is no continuous cycle or closed loop will be followed in our pneumatic system. Okay, so these are all the basic two-dimensional diagram of our open loop system. Generally, here we are having input or reference point. So we are giving the input as well as the reference point. After that, we are having the different types of transducer and controllers are used to control the entire process. Then again, this is the summing junction, which means we can connect all the input values with the reference value. We can do some of the process or plant. So individually, we can use the open loop, closed loop system for not only the control system, we are using the different applications. So for that purpose, we are using the manufacturing sector also. So that's why we are mentioning the process or plant. Okay. So after that, here we are using the again on summing function, which means summing function means we can incorporate with our input as well as the process. Finally, combine these two things, we will get the output. So directly the output will be displayed by using the DDA process, which means digital transformer analyzer will be display the results. So the results will be not compared to the reference point. So the accuracy level will be maybe varied from 80% to 100% in our open loop system. But in our closed loop system, these process points are same. Here also we are giving the input or reference point as well as the input transducer, controller, process plant. We are having also two summing points. Additionally, we are using the output transducer or sensor. Here we are giving the output signal to the output transducer. It will be comparison between the results. We are already setting the reference value as 95% means the output value will be getting only 85% means again the cycle will be again and again it will be recirculated At the end of the level, it may be attained 95% means automatically the result will be published, or otherwise again and again it will be recirculated. This is the major difference between the open loop system and the closed loop system. Okay, so these kind of control systems are used in our CNC system. Furthermore, we are using the NC system. There only we have to use the tap reader to give the inputs. After that, we have to use the computer assisted control system, which will be computer numerical control. So here we are using the computer's keyboards are used to give the inputs. After that, we are using the incorporated with the closed loop system. We are combining these CNC machines. All the CNC machines are controlled by one single system, PCR. Computer assisted system, that will be called known as DNC system. This is also one of the best example for our closed loop system. Okay, so if any doubt in this open loop or closed loop system, no. So this is the some two types of control systems are followed in our CNC system. In our next class, we have discussed about the CNC interpolation, how we are interpolate the CNC hardware, softwares, and are discussed on the next class. Okay, thank you.